Yes, dear students, very good morning. You are most welcome on this class of Is Matter Around Us. We are going to learn today about solution. We'll discuss about the solution in detail, and I will make the concept clear to you. But thing is that you will have to be very careful, you will have to be attentive, and you will have to be remain and continuous in my class. And this is a very interesting portion of the chapter, so try to learn it. Okay, so let's start today's topic of discussion, that is solution. Yes, students, solution, which can be divided into three categories as per the size of particle. Mind it, as per the size of particle, this solution can be divided into three categories: true solution, suspension solution, and colloidal solution. Today we will discuss about all these types of solution by keeping chemical nature of the substance in mind as well as the size of particle also in mind. So try to listen me carefully. See, first of all, let me tell you about true solution. To whom you will call true solution? Yes, students, you might have heard in my previous class, I have told you, I have explained about the homogeneous mixture, and you came to know that homogeneous mixture is a mixture in which composition remains same throughout the mixture. Wherever which portion you will see, you will find the same composition throughout. It is same throughout the mixture. That is your homogeneous mixture. You cannot see the particle present in the homogeneous mixture because those particles are nicely mixed in the homogeneous mixture. There won't be any distinction of boundaries, right? So first you will have to understand here that true solution means all the homogeneous mixture are true solution. Let's discuss what are the properties of these true solutions. So first you came to know that they are homogeneous in nature, means its composition is same throughout. I will take one example. Now I am going to give you one example to make you understand. See, if I have two beakers, one beaker contains solvent and in another beaker I have taken some solute. What I would get? I would get a solution which is named true solution. Dear students, this true solution is obtained when solute is dissolved in solvent. Two new words are here, solute and solvent. See, solute is the substance which dissolves in solvent. Solute is a substance which dissolves in solvent, and solvent is the substance in which solute dissolves. See the difference. Solute is the substance which dissolves in the solvent, and solvent is the substance in which solute dissolves, and you get the true solution whose nature is homogeneous. Its composition will be same throughout. There won't be any distinction of boundaries. Okay. Now let's take one example of this true solution. You get the sugar solution. Sugar solution. Can you say me, in sugar solution which will be called solute and which one will be called solvent? In sugar solution, say in sugar solution, this sugar is called solute. This sugar will be called solute, and the water in which this sugar is being dissolved to get the sugar solution is called solvent. So in sugar solution, which is called solute, sugar is the solute, and which is solvent here, water is the solvent, and you are mixing sugar in water. Then you stir it, mix it. Finally what you see? You find a clear solution, no, whose composition is same throughout. You just take that container and just look that container. You will find its composition is same throughout. there is no physical boundaries present in that. So, true solution is obtained by mixing solute into solvent. And students, there will always be the solvent in larger quantity. In sugar solution, which will be in the larger quantity? The solvent water. So, remember, solvent always remains in the larger quantity and solutes are being dissolved in those solvents. Okay. So, that was all about true solution. Now, come to the particle. What is the size of the particle of true solution? As at the beginning of this class I had told you, we will discuss about the solution by keeping size of the particle in mind. So, let us talk about the size of the true solution. Size of the particle of true solution. Yes, students, size of the particle of true solution will be less than 1 nanometer. It will be less than 1 nanometer. 1 nanometer. This unit is very small unit. This nanometer stands for very less, very low, very small unit. Yes, you can verify that. In sugar solution, can you view any particle in that sugar solution? It is quite impossible. You can't see the particle of sugar solution, that is the particle of true solution, through your naked eye. Why it is so? Because the size of the particle is less than 1 nanometer. That's why you are not in a position to view the particles which are mixed in the true solution. Okay. So, this was all about true solution. One more thing. Can you separate, or let us take the paper, filter paper, and just pass this sugar solution through that filter paper. What will you find? You will find that this true solution will pass through that paper, because you cannot separate the particles of the sugar solution. That is, the solute cannot be separated here, because that solute has been dissolved completely and you will get the uniform composition throughout, right? So, this was all about the true solution. Now come to the suspension solution. Suspension solution. Yes, let us take the example of suspension solution from our day-to-day life. But before that, in short, first I will introduce this with you. Just imagine that there is a non-soluble particle, and you are mixing it in water. You had a non-soluble particle and you are trying to mix it with water. What will happen? Will that non-soluble particle will dissolve? There is no question, because that is non-soluble. So, particle won't dissolve there. For example, let me take the example of sand mixed in water, or just chalk powder in water. Yes, students, take 2 beakers. Okay, this is solvent. You have taken some water here in first beaker, and then you have taken some chalk powder here, some chalk powder. Then what you are going to do here? You are mixing this chalk powder in the solvent, that is water. What will you observe? You will observe that this chalk powder will not be dissolved. It will remain suspended there. It will remain suspended there. Particles will remain suspended in the solvent, because chalk powder is not soluble in water. So, it won't dissolve in this solvent water. It will remain suspended in the solution, which can easily be seen through the naked eye. Yes, students, the size of the particle of this suspension solution, which is obtained by mixing a non-soluble substance in water, you get a solution named suspension solution, and the size of the particle of this suspension solution can be viewed through the naked eye. You can easily see that, because when you leave it, suppose you have mixed that chalk powder here in this water, okay, this is the solution, okay. This solution is obtained by mixing chalk powder in water. Our solvent is water here, and you came to know that this chalk powder has not been dissolved there. It will remain in suspended form, okay, and the particle of chalk can be visible through your naked eye. Why it is so? Because the size of the particle of this suspension solution is very large in comparison with the size of the particle of true solution, which we discussed earlier. So what is the size here? It will about more than 100 nanometer. Yes, students, remember this. The size of the particle of this suspension solution is more than 100 meter. Hence, you can easily view the particles present in the suspension solution. Okay. Now, leave it for some time. Leave this solution without disturbing it. Just keep aside and just watch there. Watch after 5 minutes. What will you observe? You will observe that this chalk powder has been deposited at the surface of this solution inside the container. It will be suspended at the bottom of the container. Okay. Why it is so? Because the chalk powder, which is non-soluble in water, when it was mixed in water, you get a suspension solution. The size of the chalk powder is more. That's why you can easily view through the naked eye, and the size of particle is more than 100 nanometer. Hence, you can view the size of the chalk powder which has not been dissolved. It remains in the suspended form in the solution, and when you kept it for some time, say for 5 minutes, what will you observe there? You will observe that the chalk powder is settled at the bottom of the container. This chalk powder, which is non-soluble in water, now has been settled at the bottom of this container. That is the property of this suspension solution. So, dear students, how will you get the suspension solution? In summary, you may say that suspension solution is obtained by mixing a non-soluble substance in water. You get a suspension solution. And example is here, when a chalk powder, if it is dissolved in water, it won't dissolve, it will remain suspended, and after some time, those chalk powder will settle at the bottom of the container. So, that is the property of suspension solution. Now, let us come to the filtration of this. Filtration, I am using a new word, filtration. Filtration. What do you mean by filtration? There is a filter paper. Now, you try to pass this solution through that filter paper. You take another beaker and just try to decant this solution by using that filter paper here, by some arrangement. Okay, what will you find? You will find that this can be filtered by using the filter paper. What about true solution? What I had told there, that true solution, the solution will pass through this filter paper, because all the particles are mixed properly and the composition was same. So, through filter paper, the particle of true solution has passed. But here in this case, suspension solution, what will you observe? When this suspension solution is allowed to pass through the filter paper, what will you observe? You will observe that this can easily be filtered out. By using filter paper, you can easily filter the chalk powder which was not soluble in water from the suspension solution. Okay. So, this was all about suspension solution, and don't forget, it is a heterogeneous in nature. We have already discussed about heterogeneous property. In my last class, I had explained about homogeneous nature and heterogeneous nature. In homogeneous nature, you came to know that the composition was same throughout and there was a uniform solution. But in heterogeneous, you just remember, I had taken sand there. No? Do you remember that? In my last class, I had explained about heterogeneous nature. Your sand was, your soil, soil. When you take some soil, and if you see through that soil, you will find that it is a mixture of different types of substances, which was not mixed properly. Its composition was not same throughout. That's why here the suspension solution can be categorized as heterogeneous in nature, because when chalk powder was mixed in the solvent water, it was found that they remained suspended in the solution and the composition was not same throughout. There was some portion where the amount of chalk powder was more and there was some portion where the amount of chalk powder was less, because the composition was not same throughout. Hence you can say that the nature of the suspension solution is heterogeneous. Try to remember this term, right? Now come to colloidal solution. Yes, student, the third type of solution is colloidal solution. So far we have seen about true solution, then right now I have discussed about suspension solution. Now I am going to discuss about colloidal solution. Just concentrate here. Yes, students, look here. This colloidal solution, what do you mean by colloidal solution and how will you get the colloidal solution? Yes, how will you get the colloidal solution? Yes, just I am giving you one example. Through example you try to understand here. You just take a beaker and in that beaker you add some milk. You add some milk in that beaker which was containing water. This contains water. You had water in a beaker and in that beaker of water you have added some amount of milk. What will you observe? What will you observe? You will observe that this milk remain in suspended form here also. It was not mixed properly. This won't mix properly. Okay. So this milk will not be dissolved in water properly. You just see this experiment. You can easily perform this experiment at home. You take some water in a glass and then add some milk there. What will you find? You will find that milks are not mixed throughout in the same manner. Rather, it remains present, but it has not been mixed properly. Okay, but the size of the particle of milk cannot be visible through the naked eye. Remember, the size of the particle of this suspension solution was visible through your naked eye. But here in case of milk, when milk was added in water, you will not find the milk particle. You cannot see the particle of milk. Why it is so? Because the size of the milk particle is very small. Its size can vary in between 1 nanometer to 100 nanometer. The size of the colloidal solution, the particle of the colloidal solution is in between 1 nanometer to 100 nanometer. Hence, you cannot view the particles of this colloidal solution. But students, if you perform this activity at home, you will find that as soon as milk was added in water, that came into a peculiar type of motion. Those milk substance which was added here will now be in a motion. That motion is called Brownian motion. Brownian motion. You know what is Brownian motion? It is a zigzag motion. zigzag motion. You won't have any pattern, you will not find any pattern. The milk particle will be in Brownian motion, or the particle of colloidal solution will be in a Brownian motion, that is a zigzag motion, and this is the property of this colloidal solution. It is neither homogeneous nor heterogeneous, okay, but it is a new type of solution called colloidal solution, and that was obtained by mixing milk in water, right. Now let's discuss some other property of this colloidal solution. One property was the motion of the particle was zigzag motion, which was called Brownian motion, and this type of motion was not shown by the particle of suspension solution and the particle of fruit solution. That Brownian motion will only be shown by colloidal solution, particles of colloidal solution. Now let's discuss about the size of the particle. The size of particle is here also less, but as comparison with true solution, it is little bit small, but you can't see the particles here through your naked eye, because the size of particle is still in small, that is the size will be in between 1 nanometer to 100 nanometer. Then come to the filtration. How to filter the particle of the colloidal solution. Here you have seen that when you were using filter paper, all the solution was passed through the filter paper, and when you have passed the suspension solution through filter paper, what have you found? There you found that the suspended particle was filtered through that filter paper. But what's about this colloidal solution? How to filter the colloidal solution? Can you filter it through the common paper? No. There is a separate method called centrifugation method. Centrifugation method. Centrifugation. By this method only you can separate the particles of this colloidal solution. Okay. Dear student, there is another peculiar property which is shown by only this colloidal solution. Do you know that property? Yes, that property can be performed by one experiment. If it is a colloidal solution where in water you have mixed milk, and if you just pass the beam of a torchlight, just pass the beam of torchlight through this colloidal solution. Dear student, try to concentrate here. This is a colloidal solution, and through this colloidal solution you are passing the torchlight, and just come to this way, that's the opposite of the torchlight setting. What will you find? You can easily view the path of the light. You can view the path of the light here, and this path of light can only be visible in the case of colloidal solution. This is the important property of colloidal solution. What is that property? The path of light can easily be seen through the colloidal solution, but this path of light was not seen in the suspension solution and in the true solution. Means if you pass the light of the torch through true solution or through suspension solution, you won't find the path of the torchlight. It will only be shown through the colloidal solution. Okay, so dear students, this was all about solution. Today we have discussed about the different types of solution based on the size of the particle, and no doubt we are discussing this in chemistry, so we will also keep in our mind the chemical nature, the chemical behavior of the substance. And here, while discussing about the types of solution, we have also kept in mind the size of the particle. So based on the size of the particle, the solution can be divided into three categories. Number one, true solution. Number two, suspension solution. And the number three was colloidal solution. So solution can be divided based on the size of the particle in three ways: true solution, suspension solution, and colloidal solution. You came to know about the true solution. You came to know that in true solution, solid will be dissolved in solvent. True solution can be obtained by dissolving solute into solvent. As I told you, what is solute? Solute is a substance which will be dissolved in solvent. What is solvent? Solvent is a substance in which solutes are dissolved. Okay, in sugar solution, when you are mixing sugar in water, which is solute? Sugar is the solute. Which is solvent? Water will be the solvent. And the solution obtained will be of which type? It will be a true solution, because sugar will be dissolved completely. Its composition will be same throughout. And can you see the particle of the true solution? No. It is quite difficult to see the particle of the true solution because of the size of the particle. The size of the particle of true solution is less than 1 nanometer. Nanometer is the unit which is used to express the very lesser length. Okay, so that was all about the true solution. Then come to suspension solution. You came to know that in suspension solution, you will be mixing a non-dissolved, non-soluble substance in solvent. Say for example, when you are dissolving chalk powder in water, your chalk powder is not soluble in water. What happens when it is dissolved in water? No doubt you get a solution, but the solute which is here, what is that? Chalk powder, which it will not be soluble in water. The particle of chalk powder will remain suspended in the suspension solution, and if you keep it for some time aside, what you find? You find that those chalk powders are settling at the bottom of the container, and those particles can easily be filtered out with the help of filter paper. It doesn't show Brownian motion, and when a beam of light is passed through the suspension solution, the path of the light cannot be visible here. Okay. Now come to colloidal solution. Yes, students, you came to know that in colloidal solution, the particles remain in suspended form. It doesn't dissolve completely, but because of the less size of the particle, it cannot be viewed through the naked eye, and the size of the particle is in between 1 nanometer to 100 nanometer. But it possesses some unique property. The particle of the colloidal solution are in Brownian motion, means there will be zigzag motion of those particles of the colloidal solution substance. And when a torch of light, when the beam of the torch of light was passed through this colloidal solution, it was obtained that the path can easily be viewed. Okay. So dear students, for today this much only. Just go through this in detail at home. Try to read this chapter once again, and thank you very much. Have a nice day.